All right, so from the top. Given some equation, first step is to take the derivative with respect to time, not any individual variable. Okay. Once you find that, you'll plug in these numbers and find the specific dy dt or dx dt. So derivative of this guy is 4x times dx dt. So that's our implicit piece. This guy will be 2y, right, times dy dt. Does that make sense?
Yeah, makes sense.
Okay. So part A, plug in everything and then solve for this guy. So it'll be 4 times 2. They did not give us y. So we would have to find it first. Yeah, let's do that first. Step 1, find y using x. So 2 times 4 plus y, which we're looking for. I don't need parentheses. Equal to 8. So that would be 16 times 2, right? Minus, so that would be y squared equal to 8 minus, oh man, we're going to have a problem. Do you see the issue? This would create a negative, right?
Say that again. That's what?
This is going to be negative, correct?
Oh, yeah.
And I can't square root it. I made this question up on the fly, and that's what happens. So I need to make an adjustment. Let's make this 40 and make this 3. So now I have 40 minus 32. So y is equal to plus or minus the square root of 8. All right, so essentially you would just solve for dy dx for step 1. So x is 4, dx dt is 2, y will just use the positive 8, which is 2 root 2. Okay. So part A, use the derivative of the starred one. So plug in everything. 4 times 4 times dx dt, which is 2, plus 2 times 2 root 2 times dy dt, which is what we're finding, equal to 0. So solve for dy dt. I'm out of space here. Do you agree that it would be equal to 4 times 4 is 16 times 2 is 32. So negative 32 over 4 root 2. If you were to rationalize, that would be negative 8 root 2 over 2, which is negative 4 root 2. Now, anyway, the do you see the main idea? This other stuff is just kind of plugging in numbers, right? Who cares? Does the main idea make sense? Can you take the derivative with respect to time and get this? Are there any issues with this? Okay, so after that, you just plug in some numbers. So let me show you the homework. I think with square root y, that was kind of boring. Let's see. Oh man, they had a number 3 looks exactly like the one I made up. This would have been nicer. Oh well. Let's do number 2. Maybe we'll do 3 too. Given xy equals 8, part A, find dy dt given x is equal to 8, dx dt is equal to 13. Now, if x is 8, what would y be equal to? It's close, but plug in 8. Yeah, it's going to be 1. Does everyone see why it's 1 for y? Put in parentheses because you have to solve for that. It's not given. Okay.
So it's one because it's not given, or it's just the coefficient of y.
No, you have to solve for it. Here, let me go ahead and do it. You plug in the 8 for the x, and then you solve for y, right? Just divide both sides by 8, and you'll get this. That makes sense, or no?
No, it makes sense. Yeah.
Okay. Part B, they give you the x, and they give you dy dt. So if x is 1, what would y be equal to? Yeah, it would be 8, right? Plug in the 1, obviously. Okay, now we can get started. Having everything up front is a little easier. So take the derivative of both sides. What type of derivative do we need to do on the left-hand side? And you see x times y, right?
You mean like the product rule or
Yeah, it's gonna have to be a product rule, correct? I
yeah.
just need to do it implicitly. So let's write out the formula first. So derivative of the first times the second plus derivative of the second times the first. Obviously, this will be 0. So derivative of x is a 1, right? Times dx dt. So I'll put the 1 there for emphasis. What's the derivative of y with respect to time? Derivative of y. Um, oh, I see what you're saying. Well, I mean, you're technically right. So that would be 1 times dy dt. But yeah, in the next step, we'll plug it in. Okay, so at this point, they want us to solve for dy dt. So just plug it in, plug everything in, see what this is. No, they want, yeah, they do that. Okay. X is 8, right? This is a, well, I guess I should do that on the next step. I'm sorry, getting ahead of myself. So this is the derivative step here. The first step, find the derivative with respect to time. So dx dt is equal to 13. Y is equal to 1. They want dy dt. X is equal to 8. So do your algebra and you'll have dy dt equal to negative 13 over 8. I skipped the algebra step. Is there any questions on part A? Very cool. So part B, do the same. Not a space though. Let me know if you have any questions on the first page. Is that it? Dx dt y, dy dt8. Oh, sorry. X. And they said that for dx dt this time, the y we got was 8, right? dy dt, that was equal to -9, that's right. X was a 1. So dx dt is equal to 9/8 after the algebra step. Any questions on example 2? All right, let's move on to some real word problems then. Okay. So the radius r of a circle is increasing at a rate of 5 centimeters per minute. Find the rate of change of the area when r is equal to 38 centimeters. I'll copy and paste it in the chat so you can see it better.
You said that was 5 centimeters. 5 centimeters.
5 centimeters per minute. Yeah, let me copy and paste right here. Okay. So they're talking about area. Find the rate of change of the area. So that should be your hint. We're going to need this and this. So what is the area of a circle? What's the formula?
Is it 2 pi r? It's been a while.
It's close. It's 2 pi r is the diameter. I believe it's pi r.
Was it pi r square? I'm sorry.
Yeah, is that what you said?
Yeah, pi r square. Sorry.
Okay. Confirmation always makes me feel better. So we have rate right here, a rate of 5 centimeters per minute. Okay. Radius r of a circle is increasing at a rate of 5 centimeters per minute. So we have a radius of 38 centimeters and a rate of change for the radius. That makes sense. I guess I'll just put number 5. Throwing space out there. You guys are understand that this is a rate of change, right? DRDT. So take a derivative because they want the rate of the area changing. So take the derivative with respect to time of both sides because they want area. So this will be simply dA dt, right, times 1 equal to 2 pi r dr dt. Now I do your power rule, bring down the 2, right? I just put the 2 in front just because. Now just plug in your radius and your rate, and you'll know the rate of the area changing. Okay, what is 5 times 38? I guess I could do 2 times 5 is 10 times that is 380 pi centimeters squared over minutes. 380 times pi. Don't know what that is. So if you want the more approximation, let's multiply the pi. Are there any questions on this problem? So for the test, feel free to write down perimeter areas of circles or whatever, different shapes, spheres. Okay, moving on then. Number 6, maybe I do that next. The radius r of a sphere is increasing at a rate of 6 inches per minute. Part A, find the rate of change of the volume when r is equal to 10 inches. No worries, Alice. I haven't read it yet, but no worries. Find the rate of change of the volume when r equals 36 inches. Okay. The first thing we need to do is take a derivative of which formula would you use, actually? What do you think? Because you have to choose the formula and then do your implicit derivative. No guesses? All right.
Would it be the same as the top the one we just finished, or
Well, that one was a let's see. They were talking about area. Yeah, I'm talking about radius, but then they mention volume down here. So the questions that we're answering are right here. So look at whatever question they're asking, and that'll help you determine. So find the rate of change of the volume.
so dv dt?
So we need what is the formula for volume of a sphere? That's what we need. But yeah, dv dt, exactly. But first, what is v? I think it's like 4/3 pi cubed or
Pi
something.
r square, pi r cubed, I believe. Yeah.
Is there a 4/3 or a 4 or something?
4/3 pi r cubed.
Okay, thanks. That one I always forget. I don't use it too often. So we are given, so use this to answer A and B. We are given an R radius rate actually. So d r dt. In part A, we're going to use this specific r. But before you get there, you got to take the derivative of both sides. That'd be dv dt equals 2 4 pi r squared dr dt. I skipped a minor step. You guys cool with this derivative, this implicit derivative? Okay. So now we can answer part A. I'm running out of space. I'm going to jam A right there. Find the dv dt and plug in r. And dr dt, which is 6. So this will be what? 100 times 6 is 600 times 4, 2400. I think that's right. Okay, let me see if they wanted us to round or not. I feel like that'd be fine, but if they don't like it, multiply 2400 times pi. I don't know. Or B, same deal, just change the numbers. Be 4 pi times 36 inches squared times 6 inches. That will be, I don't know. Pretty big number, huh?
311. How'd you get 90?
Oh, you know what? I multiplied the pi. What'd you get?
311.04 pi. 311.04 pi.
311.04 pi.
And if you were going to round it off, because I saw you writing a 9, were you going to do that or no?
No, let's just say consistent. I didn't do it here, so it was just accident. But you see the idea for the word problems?
Yes.
We'll just figure out what formula they're talking about. If it's like if they want you to find like on the first question up top, they mentioned find the rate of change of the area. So that's what told me. Use the area of a circle, take your derivatives, plug in what they gave you, and you should be able to answer dA dt. This means the rate of change of area over time. And then here, they gave me the rate of the radius changing, and then said on part A, find the volume when your radius is this big. So that means I need to do dv dt to find rate of the volume, rate of change. So that's why I took the derivative, got to here, and now I just plug in the numbers that were given in part A and the question. In a nutshell, that's all we're doing. Any questions on part 5 or 6? Okay. I think
I don't remember any, but you might have, I don't know.
okay. I think this is it. Just download this. I might have sent it during the limit time, maybe not, but if you open it up, I'll share the screen too. So here they take the derivative of x, it's equal to 1. Derivative of sine is cosine, right? We have all these written down. Derivative of inverse sine, this is the new stuff. But notice we're just using a formula. So derivative of arc sine or sine inverse is just this. Okay, now there is an additional piece. Let me see if I can find it. That incorporates the chain rule. No, I don't think they're on here. But basically, let's say there was a 2x in here, right? Your derivative would be the same thing, except you'd have a 2x in that squared piece, and then times the derivative of 2x. That's the only difference. So to complete the formula, you would add, add times the derivative of x. So in this case, derivative of x would be 1, right? So that's why it's not there. These right here incorporate the derivative. Do you see that? So this is a more complete formula. So whatever u is in there, you just do times, you put the u prime on top. That's it. So if it's a 2x or a x squared, just put a derivative of that argument here. Or just do the chain rule, doesn't matter. But this section is a lot easier. This is 3.7. Derivatives of inverse functions. Let's go ahead and show it then. So notice here the argument for number 1 is x minus 4. So you would use the formula, but to put the derivative of x minus 4 on top. This formula would be the derivative of negative t squared. Here, derivative of x over 2. Just put that piece into the formula and you'll be good. So open the link I sent or the PDF, either one. Find the derivative of f of x equal to x minus 4. So the derivative with respect to x would be equal to, look at the formula, would have the derivative of the argument up top. So derivative of this thing divided by the square root of 1 minus x minus 4 squared. So this will become df dx equal to 1 over the square root of 1 minus, I guess you could FOIL that out. X minus 4 squared, that's going to be, all right. Anyway, is that this makes sense? Yeah. Let me know. Let's do G, I guess. Okay. The derivative arc cosine is the same as before, except there's a minus in front. So the derivative would be equal to, that 4 is going to come along for the ride, so it'll be negative 4 times the derivative of this argument over square root. Oops, sorry, let me switch back. Right, using the formula. Derivative of the arc cosine is that formula thing. Derivative of this argument over 1 minus that argument squared. What is the derivative of x over 2? All right, so derivative of x over 2 is 1/2, right? So negative 4 times 1/2 over the square root of 1 minus x squared over 4. So that'll be -2 on top. Square root of 1 minus x squared over 4. You may have to do some algebra to combine this before it accepts it. I don't know if it'll take it just like this. But essentially, this is the answer. Is there any questions with the setup and how we're using them? Or using the formulas? Okay. All right. So far the section is pretty easy, right? It's not crazy. I mean, I can't tell if it's super easy or super hard. Just let me know. But it's pretty much the same thing over and over again. Do you have any concerns with 4 and 5? Does this look doable? Yeah, let's do 4. You write it down, now switch back. On the derivative of all right, so you see this is a product rule, right? So I'm going to stick with the Leibniz notation since we've been using it a lot. Derivative of both sides, that would be e5x derivative arc sine x derivative. Okay. So this just becomes dg dx or g prime, right? This is a product rule, so the formula says derivative of the first piece times the second piece plus the derivative of the second piece times the first. What is the derivative of e to the x?
Just 1 e to the x.
Yeah, pretty much, right? Just itself. Derivative arc sine is a formula, right? So that'll simply be 1 over square root 1 minus x squared e to the x. Okay. Oh, sorry, my mind's elsewhere. You guys cool with this? It's pretty much the answer. Put the EX on top, I guess. Any questions on 4?
I'm sorry, Professor. Are we looking at 3.6 or 3.5?
We did 3.6 first, I think. Yeah, this is 3.7. No, did I label it wrong? Yeah, 3.7.
Yeah, no. It's just I don't see 3.7 on mine on my homework.
Gotcha.
It's at the top.
I'll refresh it.
Let me check out what's going on here. Yeah, here it is. Let me open it up. All right. So it's now posted. If you hit refresh, should be there. Okay, I think I'll leave the rest to you. If there's any, you guys have any questions on pause here? Okay. So this is homework number 11. Find the derivative. Let's see here. So I had recommended you distribute first just to make it a little more manageable. So the derivative of f of x is equal to the derivative of of this. Alrighty, so the derivative of this first piece, right, is just the power rule. I'm gonna go ahead and show this extra step just in case. So you agree that this is 7x to the 6. Derivative of this is a 9. It's going to be a quotient rule, right? Whole thing is negative, so I'm going to just leave it out there. So quotient rule is the derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. All right, derivative of this guy is going to be 35x to the 6 times this garbage. Derivative of this is a 1, right? Derivative is now done, but there's some algebra to do. You follow me up to this point?
Yeah, I'm following you.
Okay. So at this point, just distribute this garbage and then combine like terms. We may have to deal with this as a fraction. We'll see.
That's where I'm getting stuck right there.
The fraction step.
Yeah, that number outside and that negative.
What's 6 times 35? I don't know what that is.
210.
10. 210 x to the 6 minus 5x to the 7. Just about done. This will need an x plus 6 squared in order to add them, right? So multiply by that LCD minus 35 minus 5, that would be 30 plus 210 x to the 6. So now they'll have the same denominator. So this will be 7x to the 6 times x plus 6 squared minus all this garbage. By minus this, you agree that the signs will switch, right?
Yes.
The amount of space, I skipped a minor step there. All right. I think it's gonna like that. That sucks. Let's try some factoring. So you have two options. we try to plug it in this way, which I don't know if it'll like it. We expand this x plus 6 and then multiply by this, and then combine these terms, and then submit it.
And what was the other option? Was it just to get the greatest common factor?
Yeah, I was thinking of pulling out the GCF right now and then leaving it as is. Maybe it'll take it. I don't know. Let me see. I'm gonna try plugging it in as is, mainly because I'm out of space on the page. It's just this question is algebra heavy. Take this garbage. Yeah, it's cool with it as is. Nice. Does the steps make sense though?
Yeah. Um, I guess what I was doing was reducing it just a lot more, but yeah, I was getting confused on the like that 7x6 and then the negative. So I don't know why I was having such a hard time with it.
So you had this part, right?
Oh yeah. Yeah, I had those parts.
You just didn't know how to combine them, I guess.
Right, yeah.
Did it not take it like this?
Um no, I think I went um like I reduced it a little bit more. So and then I just started plugging in numbers so I could see the answer because I couldn't get it.
Yeah,
Um
I don't know how. I wonder if you would have tried this, if it would have taken it. Or I'm sorry, this one.
all right, thank you. Appreciate it.
Yeah. And I think just the same deal, just your number would be 6 there, 2 and x plus 3. So multiply it in that part in front, do your derivative on each piece. That'll give you a power rule, and then this will be a quotient. So just use your quotient formula there. Your only difference is instead of a 5, you have a 2. Instead of a 6, you have a 3. And this would be a 6, but exactly the same. Excuse me. Ugh, man. You guys need any extensions on anything? I mean, we are a little bit ahead of schedule, so yeah, I wouldn't mind doing that. Let me do that, and then we'll call roll and see if you guys are good.